Distillation separates liquids based on differences in volatility. Consider a liquid mixture of A and B. Boiling point of A is 70 degrees centigrade. Boiling point of B is 100 degrees centigrade. As a mixture begins to boil, the vapor phase becomes richer in A than the liquid phase. Condense vapor phase to get a mixture with a higher concentration of A. As the temperature increases, the concentration of B in the vapor phase increases. So what would be the composition of the vapor phase if the entire component is distillated? So distillation equilibrium stages. Phases are brought into close contact. Components redistribute between phases to equilibrium concentrations. Phases are separated carrying new component concentrations. D. Analysis based on mass balance. L is the stream of one phase. V is the stream of another phase. Use subscripts to identify stage of orientation. So material mass balance is equal to L0 plus V2 is equal to L1 plus V1 is equal to M. So this is the diagram for input and output from each stage. So the vapor comes from the bottom stage, whereas liquid comes into the stage from the top column, top tray. So this is the distillation. This is the graphical way of identifying the number of stages. So first of all, we have to draw the graph x versus y. The more component volatile, more component in the vapor phase, whereas x is the more volatile component in the liquid phase. So this is the graph which obtains when the graph is drawn. So this is the equilibrium graph. So next we have to calculate number of stages between XD molecular, the more volatile component in the distillate, whereas XF is the more volatile component in the feed, where XB is the more volatile component in the bottom products. So we have to draw the graph between these operating line, equilibrium line versus this operating line. So then we get number of stages for the required separation to happen. So this is the way of calculating the number of stages for given separation of mixture into individual components.